This is Algebraic Reasoning, Chapter 1.3, Exercise 11 through 21. Again, we're looking at determining linear functions from data. And in this set from problems 11 through 21, there are four big problems that depend on this. I'm going to do two sets of those four. I'm going to work on this first set, which includes problems or questions 11 through 13. And then another set later on is going to be 18 and 19. So here we are. Use the following situation to answer problems 11 through 13. Jeff noticed that the nutrition information on his box of cereal states that there are 14 servings in the cereal box. He decided to put their claim to the test. He recorded the weight of the remaining cereal after each serving as shown in the table below. Here you have a table. It says write a function rule that models the situation. And then questions 12 and 13, we're going to go over all those. First of all, we're going to look at the change in amount of cereal over number of servings. And so we have between 5 minus 0, so we'll say 5 minus 0 equals 5 total servings. That's what we're going to be looking at. And then, what is the weight left? Well, that would be this increment here. Okay, we started with, well, we're going to have the change is going to be 8.4 minus our initial amount, which is 14. And so change in cereal divided by the change in the number of servings. So we will say 8.4 minus 14 over 5 minus 0. And we're going to call this our slope, our m. Well, just kind of doing this right here. Let's see, 8.4 minus 14. If we reverse it, take 14 minus 8.4, make it negative 14 minus 9, that'd be 5 plus another 0.6. We're going to say negative 5.6. And we're going to divide that by 5. So our function that models the situation would be, what is 5.6 over 5? It's going to be 5. It's going to be 1.12, I believe. Let's go ahead and put this out here. We'll have 5.6 and 5. That's going to be 1 and 5. Okay. And then we're going to bring down this 0.6 or 6. How many times is it going? 1. So 0.1. 1 times 5. 5. Down 1. And then we bring down 0 from above. So we're going to get 1.12. So say m is equal to negative 1.12. And we know that our initial amount, our B in this, is going to be B equals 14 ounces left over. So we can write that out. So our answer to 11, I'm going to write it right below 11. We'll say weight. We'll call this weight. And servings, number of servings we can call N. So our weight is equal to negative 1.12 servings plus our starting amount of 14 ounces. So that would be our answer to number 11. Okay. Trying to draw it so I can still read below. What does the slope of the y-intercept mean in the context of the problem? Well, I'm going to translate this to English. the slope is slope equals how many ounces per serving, right? How many ounces, I'll abbreviate OZ, per serving. And of course, it's an average. That's part of what we're trying to understand. And the y-intercept, so let's say y-intercept equals starting amount, right? Starting amount, I'll put AMT. Okay, so that's going to be slope and our y-intercept in the context of the problem. 13, was Jeff able to confirm the claim on the cereal box by eating 14 servings? Well, 14 servings, there are 14 servings in the cereal box. And you start with 14. Well, let's go ahead and put 14 servings in here. We're going to say, where we have that equation, W equals negative 1.125 S plus 14. I think I know what's going to happen here. If we say, in this case, weight, and we plug in 14, we get negative 1.125, not 125S, 12S. Kind of mixing things up. There we go. 1.12S. So 1.12 times 14 plus 14. Well, 1.12 times 14, I'm going to work this on the right here, we get 2 times 4 is 8. And 4 times 1 is 4. And then 1 times, maybe go over 1 times 2 is 2. 1. So we add these up, we get 8, 6, 5, and 1. So what do we have here? We have negative 15.68 plus 14. What is that going to be? That's going to be negative 1.68 ounces. So explain your answer. Was JP able to claim? No, he wasn't able to confirm because he used too much cereal. So no. And why? Explain. 14 servings more than depleted the box. Depleted the box of cereal. Okay, so that's 11 through 13. Let's go on to do the 18 and 19. Okay, 14 to 17 is this one here about a hurricane tracker. Here we have use situation, following situation, answer problems 18, 19. Maddie is running a 10K, 10-kilometer race. She wears an electronic chip that tracks her progress throughout the race. She runs at a fairly steady pace as shown in her chip data below. Write a function rule that models the situation. Well, again, similar to the way we did for the cereal box. Okay, we have 5 minus 0, so we have 5 kilometers total. So it's going to be 5 minus 0. And then below time, $19 minutes, so that's 19 So 19. So write a function rule that models a situation. We're going to look for our slope first. So our m is going to be our distance covered divided by let's see what a function rule would find out. And she's running a 10K race. So we want kilometers per, or we want distance divided by time, right? We want distance divided by time. And we want the best time of 37 minutes. So we want time divided by distance, don't we? So time divided by distance. And that's going to be, we can just work this out here. I think I know what it is. So that's going to go in there 3 times, 15, bring down the 4, and then bring down the 0, so 0.8. So we have 3.8, that's our m. M is equal to 3.8, and what is that? Minutes per kilometer. That's a very fast pace, by the way. Anyway, let's go look at this. Write a function rule that models the situation. So we have our we want to find out the time. So time is going to be equal to 3.8 times the kilometer. So time, we'll say minutes, equals 3.8 times the number of kilometers. So if Maddie continues at this rate, will she beat her previous best time of 37.5 minutes? And so we're going to say minutes equals 3.8 times 10 kilometers, and 3.8 times 10 is 38 minutes. So we will say no, because 38 is more time, and I'll just put greater than 37.5. So she will not beat her time. And so those will be our answers. We have an equation here, and we have no, answer no, and explaining why. So this one takes a little bit of thinking to see what applies, and then if we look at that last set here, which would be problems 20 and 21 about Nikki and wages and earnings and so forth, that's a doable problem as well. Good luck, and thanks for viewing.